In the previous video, we looked at a few sequences with this situation. We were going to hit a bad guy in the torso, which here I'm going to abbreviate that event, hitting him as H and missing as M. And the associated probability was the probability of a hit was 0.81, probability of a miss was 0.19. And again, those add up to 1 or 100% because there were no other options in this case. So the situation was we get 5 attacks. What is the probability that we... So we did this one, hit 5 times, H, 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 using the notation this time. And we did that calculation as just 0.81 to the 5th power gives you 34.9%. The probability of hitting 0 times was 0.025%, so very, very low, which is 0.19 to the 5th. It's all these other cases that are a little more complicated. If you hit 4 times, well, what does that mean? You know, we've been talking about everything in terms of sequences, but hitting 4 times would really be a lot of different sequences of events that lead to a total of 4 hits. You can see I wrote them all out here. It's hit, 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 miss, or hit, 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 miss, hit, 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 miss, hit, 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 miss, hit, 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 or miss, hit, 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 hit. And now we can calculate the probability of each of those sequences. Now this would be 0.81 to the 4th times 0.19. How that works, the sequence just 0.81, 0.81, 0.81, 0.81, 0.19, like that. And we'd get about 8% here if I go ahead and format that as a percentage as well. And now this sequence, same thing, we do 0.81 times 0.81 times 0.81 times 0.19 times 0.81. Just again multiplying the probabilities that lead us to the sequence. And it probably is not super surprising to notice that we get the exact same number. And that's because we're multiplying the same numbers just in a different order, so we get the same thing. In fact, for all of these, we could sort of shorten this to be 0.81 to the 4th times 0.19, because you have 4 hits and 1 miss. And the order in the sequence matters, like these are different things in terms of the video game. Whether the miss occurs 3rd or 4th, 5th, 2nd, or 1st are different, but the probabilities are the same. So really, this works out the same way. All of these different sequences include hitting 4 times. So the total probability of hitting 4 times would be to add those all together, which is just how that works, 40.9%. Hitting 3 times, you could do the same thing. What you do is you list all the sequences that involve hitting 3 times and missing twice. And in this case, there are 10 such sequences. So it takes a while to list them all, but we could calculate the probability, 0.81 to the 3rd times 0.19 squared. Because for each of these sequences, there are 3 hits, 2 misses. So each one of those would be about 1.92%. Each one of these has 3 hits, 2 misses. So the total probability then of hitting 3 times would be to add all those up. Now, of course, this gets rather tedious, and you don't really want to do it a lot. But you could also do it for 2 times, 1 time, list all the sequences, and then 0 times, which we did in the last video. But the thing is, this more complicated situation comes up so often that it has a special name. This is called a binomial model. So when to use the binomial model is when you're finding the probability of k successes in n trials. So you're not looking at individual sequences anymore. You just want to know how many times did you hit or complete or whatever the definition of success is, and you have n trials. So you'll check the conditions to see whether this works. You have to have n trials, so you know how many times you're going to try something in advance. The trials are all independent of each other. We'll look at a couple examples in the future where things are not independent. There have to be only 2 outcomes, success and failure. And I put those in quotes because sometimes it's not really the same as the English words. It's just convenient to think about it as something happening with a certain probability or not happening and no other outcomes. And the last one is the probability of success has to be fixed for each trial. So if the probability of something changes as you're doing it, that is not a binomial model. It's more complicated. So now in the next video, let's look at how to do these calculations much, much faster using the fact that we're in a binomial model.